Acridine is an organic compound and a nitrogen heterocycle with the formula C13H9N. Acridines are substituted derivatives of the parent ring. It is a planar molecule that is structurally related to anthracene with one of the central CH groups replaced by nitrogen. Like the related molecule pyridine and quinoline, acridine is mildly basic. It is an almost colorless solid. There are no commercial applications of acridines, but at one time acridine dyes were popular. It crystallizes in needles. Isolation and synthesis. Carl Grabe and Heinrich Caro first isolated acridine in 1870 from coal tar. Acridine is separated from coal tar by extracting with dilute sulfuric acid. Addition of potassium dichromate to this solution precipitates acridine bichromate. The bichromate is decomposed using ammonia. Acridine and its derivatives can be prepared by many synthetic processes. In the Berntson acridine synthesis, diphenylamine is condensed with carboxylic acids in the presence of zinc chloride. When formic acid is the carboxylic acid, the reaction yields the parent acridine. With the higher, larger carboxylic acids, the derivatives substituted at the mesocarbon atom are generated. Other older methods for the organic synthesis of acridines include condensing diphenylamine with chloroform in the presence of aluminium chloride, bypassing the vapors of orthoaminodiphenylmethane over heated lithage, by heating salicylaldehyde with aniline and zinc chloride, or by distilling acridone over zinc dust. Another classic method for the synthesis of acridones is the Lambert-Tananescu reaction. Reactions. Acridine displays the reactions expected of an unsaturated N-heterocycle. It undergoes N-alkylation with alkyl iodides to form alkyl acridinium iodides, which are readily transformed by the action of alkaline potassium ferrocyanide to N-alkyl acridones. Basicity. Acridine and its homologues are weakly basic. Acridine is a photobase which have a ground state pKa of 5.1, which is similar to that of pyridine, and have an excited state pKa of 10.6. It also shares properties with quinoline. Reduction and oxidation. Acridines can be reduced to the 9,10-dihydroacridines, sometimes called leucoacridines. Reaction with potassium cyanide gives the 9-CYANO9,10-dihydro derivative. On oxidation with potassium permanganate, it yields acridinic acid 2, otherwise known as QUINOLINE1, 2-dicarboxylic acid. Acridine is easily oxidized by peroxymonosulfuric acid to the acridine amine oxide. The carbon 9 position of acridine is activated for addition reactions. Applications. Several dyes and drugs feature the acridine skeleton. Many acridines, such as proflavine, also have antiseptic properties. Acridine and related derivatives bind to DNA and RNA due to their abilities to intercalate. Acridine orange is a nucleic acid selective metachromatic stain useful for cell cycle determination. Dyes. At one time acridine dyes were commercially significant, but they are now uncommon because they are not light-fast. Acridine dyes are prepared by condensation of 1,3-diaminobenzene derivatives. Illustrative is the reaction of 2,4-diaminotoluene with acetaldehyde. 9-phenylacridine is the parent base of crisaniline of 3,6-diamino9-phenylacridine, which is the chief constituent of the dyestuff phosphine, a byproduct in the manufacture of rosaniline. Crisaniline forms red-colored salts, which dye silken wool in a fine yellow, and the solutions of the salts are characterized by the fine yellowish-green fluorescence. Crisaniline was synthesized by O. Fisher and G. Kerner by condensing orthonitrobenzaldehyde with aniline. The resulting orthonitropyridaminotriphenylmethane being reduced to the corresponding orthoamino compound. which on oxidation yields chrysanoline. Benzoflavin, an isomer of chrysanoline, is also a dyestuff, and has been prepared by K-Ola from metaphenylenediamine and benzaldehyde. These substances condense to form tetraaminotriphenylmethane, which, on heating with acids, loses ammonia and yields 3,6-diamino9,10-dihydrophenylacridine, from which benzoflavin is obtained by oxidation. It is a yellow powder, soluble in hot water. Safety. Acridine is a skin irritant. Its LD50 is 2000 mg per kilogram and 500 mg per kilogram.